so this is not a talk, it's just a request. I will explain some apparently difficult thing, and then I will ask for your advice, because I have solutions, but I have also needs. So let's start with what is it, this global transaction ID. So the definition is that it's one, let's call it a number, or one ID that is generated in the source of the data. So we're talking about MySQL replication, and I hope everybody is familiar with MySQL replication with master and slave. Everybody? Yes. So we're talking about something that should be generated in the master and be unique all over the replication cluster up to the slaves. So if you have intermediate masters that are also slaves of the first master, they should not change this ID. Now, why is this important for you? Because without the global transaction ID, doing failover becomes an exercise in pain. Let me explain. I'm going to show you an example. So, normal replication, what happens? You have a master, the master writes the binary log. And you have several slaves that you want to prepare as candidates for master. As candidates for master, they have their own relay log and they have their binary log. So far, so good. As long as the replication works, everything goes fine and everybody's happy. The thing that happens is what you have in the binary log of the master is the same that you have in the binary log of the slave, but not necessarily in the same order. Actually, most of the time, is in a different order, in a different file, in a file of different size. So if you look for position 1000 in the binary log of the master and position 1000 in binary log of each of the slaves, you find different things. This is, how do we call it, a design bug, a design feature, depends on who you ask. For me, it's a bug, it's a missing feature, it's something that doesn't exist yet. So what happens? The master crashes because every hardware sooner or later will disappear. What do you want to do? You want to promote one of the slaves. So you inspect the binary logs of the slaves and try to find out which ones are the most advanced. So you inspect the, actually this slide is longer, you don't inspect the binary log, you inspect the relay log to see the latest that each one has got from the master. So in this case you say slave number 3 is the one who has got the most. You promote slave number 3 to master. Now you have to synchronize the 2 other slaves to the master, with the new master. How do you do that? Now, this slave number 2 is missing 2 transactions. Slave number 1 is missing 3 transactions. How do you find where these transactions are in the binary log of the new master so they can get synchronized? The position is different in all 3 documents. So you don't know exactly where to look at. So what you need here is a mechanism. You need a master global transaction ID that tells you where is the place where you have to synchronize these slaves to the new master. Is the concept clear? Okay, now, if you don't have this, you really have to do a painful research in the binary logs and find the exact position where you have to synchronize each of the slaves to the new master. And doing that manually takes you sometimes hours. If you do that with some scripts and you are lucky enough that your transactions can be sort of different, that you can identify them, then you may do something automatically. There is a solution, an old solution actually. Google has made a global transaction ID patch. Unfortunately, this patch only works for MySQL 4.0 and cannot be ported to 5.1 because the way it is designed, it doesn't work with the row-based replication. So you can apply to 5.1, but if you use you can use it only if you have a statement-based replication. If you start using row-based replication, it doesn't work anymore. So this is where we go to look for a hack. There is a book that was published a few months ago. It's been written by the people who have written MySQL replication. Chuck Bell, Matt Skindal, and Lars Stallman. So these are the people who have not designed the global transaction ID inside MySQL, and they offer a hack. The hack is like this. If you want to create a global transaction ID, you have to prepare your database with two tables. One table is a MyISAM table with an auto-increment field. Another table is called last executed transaction, which is an InnoDB table. What do you do with these two tables? Before committing, actually instead of committing, you use this procedure. So instead of calling commit, you say call commit trans. And what does commit trans do? Let's go line by line. First of all, it will isolate what is happening here from the binary log. So set SQL log bin equals 0 means from now on don't write the binary log. What do we do outside the binary log? We will insert inside the MyISAM table one thing, one node. This will generate insert ID. So we do select last insert ID into a local variable. And the server ID into another local variable. Then, to avoid the growth of this table, we will delete the last thing that we have inserted into MySQL, into the MyISAM table. And finally, we enable the binary log again. So what do we have now? We have outside the binary log, we have inserted a row, got a global transaction ID, global number, and then enable the binary log. Finally, what do? We insert into the InnoDB table the value that we got from the MyISAM table. And at the end we call commit. So, I don't know if you realize something looking at this code. What is your first thought about that?
Additional I/O.
Additional I/O, yes.
Also, if your master and slave are out of sync in the first place, you know, what happens if the transaction IDs don't make it there? Or like it's only, like what if you miss one of the things on the slave or something, you know, it's not gonna...
No, this works fine for that.
Okay.
For that, I mean, it serves the purpose. If
Okay.
you generate this in the master. This goes down like a charm, down to the last slaves. The problem here is performance. Now we are inserting into a MySQL table, deleting from a MySQL table, and inserting into InnoDB table. So there are 3 operations instead of a simple commit. So this is a lot of overhead, really a lot. So as soon as I saw this, I said, stop the press. This is not good. So I decided to hack the hack. Of course, I can get the same result without that much overhead. So what did I do? I removed the MySQL table from the scheme. Instead of using a MySQL table, I'm using a UUID short function. Does anybody know what the UUID function does? Do you know that there is a UUID function in MySQL that generates one huge string that is guaranteed to be unique in the universe? Now the UUID short is a short. It's a simple number. It's not alphanumeric, and it's guaranteed to be unique within a replication system, with a thing that I will tell you later. And I moved the InnoDB table away, and I replaced that with a black hole. Now, my normal laptop has crashed, otherwise I would have showed you some test of how this works. But, you know, in the end, this is 10 times faster. So this solution, this hack, will achieve the purpose without introducing new storage problems. So you are not inserting anything because you're using a black hole table. So if you insert into a black hole table, it will go into the binary log, but you will not have any storage wasted on disk. And since you don't have to insert and delete to the MySQL table, you have 2 operations less. Since you are inserting the black hole, you don't have the overhead of inserting into InnoDB table. So it's 10 times faster. What is the problem? The problem is the master server ID must be less than 256. This is the requirement of the short UUID short function. So as long as your server ID is less than 256, this is guaranteed to be unique in your replication system. The UUID short is progressive, so it's going to be easy to identify in the binary log. So it serves the purpose with this simple disadvantage. You know why it is a disadvantage? Because many people use as a server ID the IP address converted into a number. That is very convenient, very easy to do. You just use a function and you convert the IP address into a server ID. So if you have this kind of paradigm, you have to suffer through this exception. So this is where we are now. I have one more thing. Yesterday there was a blog post that explains how to do global server ID with a third-party solution. If you look at Planet MySQL, you will find it. Basically, instead of using MySQL native replication, you use one thing that is called Tungsten replicator from Continuent. The thing that you will find here is that that replicator will insert a global transaction ID before passing the binary log from the master to the slave. So this allows an replication system quite complex to file over and file back almost painlessly. I saw a demonstration of this a few weeks ago and I was impressed. So I saw that you can just kill the master and the slaves will fall in place immediately without problems. Then you can call the master back and everything will fall in place again. So this is the solution that we have so far. I have one patch that is not updated for MySQL 5.1. I have one hack that I have improved to have a minimal overhead, but it still has overhead. And I have a third-party solution. So this is everything that I have. Now I ask you, what can you suggest in addition to this?
It's a hard problem. It's a very hard problem.
It's a hard problem. Now, probably the easiest thing to do is to hack the server and create that. I was thinking also that I can put a proxy between master and slave and inject global transaction ID there, but it's quite fragile. You know, this paradigm works because those red things that are called replicator, they are connected in the network and talk to each other. So they keep each other updated on what the global transaction ID is. So you are guaranteed that there is one global transaction ID everywhere in the cluster. If you use a proxy, you have to make some mechanism not to make the proxy a single point of failure. And to do that, you have to make the proxy redundant. If you make it redundant, you must guarantee that it doesn't lose the global transaction ID and keeps counting whenever the new proxy comes back when the old proxy dies. So it's not an easy problem.
And in Drupal, we don't have a solution for this yet. Of course, our replication code is still very young. Having to rip everything out in MySQL, start from scratch. But past week or so, I've actually been looking at this Tungsten replicator. And we're actually going to use this as kind of our first phase of replication solution. We have something working right now.
So how does Drizzle solve this problem? How does it solve it at all?
I'm sorry?
How does Drizzle address this problem?
We don't yet.
Oh.
Use Tungsten replicator.
So how is
We don't have a native replication protocol yet. So
yeah, I know, but I know that there is something. How does Drizzle deal with the failover problem so far?
So far,
Manually.
yeah,
Okay.
yeah, the Tungsten seems to be very capable of handling those types of failures to keep its own transaction history rolling. Sort of assign its own global IDs.
Well, this is a common problem to most of the asynchronous replication systems. I believe that also the non-relational database replication systems must have something like that to deal with the failover. Because if you have a synchronous system, it's relatively easy. Synchronous means that you don't commit until you have an answer from the other node. And you have a sort of gossip protocol that from the other node you propagate the change to the rest of the nodes. So synchronous is more or less painless. So whenever you are committed, you know that everybody else has been informed. When you are asynchronous, though, by definition you are waiting to the other nodes to catch up. And this works until everybody is alive. When one of in the chain of command is dead, the troops panic. Come on, folks. I traveled 3,000 miles to come here to ask for your advice. I didn't want to impose on you my ideas. I just want ideas from you. You know, this is such a common problem. I mean, everybody uses MySQL replication, and hardware fails every day. You know, my laptop crashed 2 days ago, so I know that. So this must be a common thing. Now, the Google people, they made a patch. And then the people who did the patch and migrated to Facebook, so I don't know what they are doing in Google. And I know that the people that now are in Facebook, they still want this patch for global transaction ID. So I don't know what is their solution now. Maybe MariaDB has a solution.
Christian has been working on something, but there's no solution. He's working alongside Galera, but there's no solution yet. It's something that's hopefully, he tried to work with Lars as well for a solution to change the replication API for platforming, but there is no solution.
There is no solution because there is no agreement on the solution, or just because there is no solution inside?
No agreement on the solution.
Oh, okay, so Christian has an idea of...
Christian has an idea, yes. He's put it up on the wiki as well.
Okay.
He's talking to Lars, or he has talked to Lars.
Is he doing that as part of this group network, or?
In addition to that. So, being the only person working on it, I'm guessing it's going to take a long time.
Yeah.
I see. Okay, so this is going to be in the wish list of many people for long.
But Google is starting the MySQL team up again, for what it's worth. So they might also want to work.
Okay. Any more ideas or questions or comments on this thing?
I actually read Google's global transaction ID proposal the other day. I can't remember why didn't it work with row-based replication?
I didn't look into it. I just saw a comment that says, careful, this doesn't work with row-based replication, so don't try to port it to 5.1. But I mean, I trust the implementer to that. I didn't see exactly what the problem was. And nobody from Percon is here, but I think that if it was feasible, Percon would have done that already, because they did the porting for 5.0, and they gave up when they saw that it was not feasible for 5.1, or it was too much work. So the ball is in MariaDB's court.
Whatever changes that need to be made need to work with upstream MySQL, otherwise it will break replication. It will change the replication API. So,
Well, you don't have to change the replication API. You have to inject a global transaction ID before in the binary log. So the slave doesn't have to know that something has changed, because what the master does is, whenever there is a commit, it will add a global transaction ID. Simple as that. This is the naive solution that I would use. So the slave keeps receiving the binary log with the existing protocol. There is no way, no need to change the protocol. Maybe it's too naive, but this is the way I should do it if I had to. If I was really desperate and I wanted to do that.
I guess if we had answers, we would be implementing them ourselves, really. I mean, that's certainly the way it is for me.
Okay, anyway, there is a hack that you can use. I'm gonna put that in a blog post so you can try it on your own. And could be useful if you don't have millions of transactions per second. If you're not Facebook, just to make sure. Or maybe Facebook is also something like that. Nobody knows except the Facebook people. Okay, so that was all. Thank you. If you don't have more comments, I'm done. If you need to discuss this or other things related to MySQL, I'm available. Yes?
I had a question about a particular circular kind of replication situation that we have that we can take a look at if nobody else had any questions.
Okay. So a circular replication, what is the problem?
Well, it's not really circular because we're having problems with trying to get that to function. So we actually do a replicate down. I can put it up. We just may be doing this in the wrong way.
Let's do a community testing.
Oh, is yours, that's for the, I don't have the adapter for the,
Okay.
so basically we have our production, like our web servers, the SQL hits like that, and it right to our production database. We also on this server,
So that's like so you have your production database.
yeah, and there's basically two major types of stuff in that production database.
And you have a slave.
Yeah. And there's fresh data getting written into that, and there's also into the master that's getting replicated down to the slave. Like people come to sites and they see stuff and they do stuff, right?
Okay. It's not just a button.
Right.
So
Then the slave gets this slave has a process that builds a whole different set of tables and a whole other database, a data mart database.
and
Then it's a huge one, so we copy that one back up nightly
using an application.
using FTP.
So you have an application, and this application moves data back to the master.
And we have a database there.
And this data removed gets replicated.
No, that's the thing. We don't have that replication turned on.
So what is it that you move back to the master?
Like a very, very large database of transformed data, stuff that we've done ETL. So we have basically here a reporting database. So some of our websites read pages and build off of that reporting database.
Okay.
It's always like a day behind because the ETL is pretty heavy STP'd up. It's set so this might be able to run more frequently and replicate back up to here. It's the same instance of
Why don't
MySQL.
you use federated tables?
Federated table.
Yes?
What's that? I'm not familiar with that concept.
Oh, federated tables. It's one storage engine of MySQL that doesn't store anything, just a link to a remote table.
I know, it's one of those like when people see that they're like,
Table here.
really?
That is just a link to a table here.
Right, like why would you do, how do you guys have a database that works when you don't have things like this?
A link for the master. So the only thing that you have to do, you have to exclude this.
No, it's, you're totally right, no, I'm just playing
Otherwise,
with
you will have
the, making sure everything is supposed to show up, that's right.
So when you build this, it seems like you're doing it locally, but it's actually storing stuff in the
Well, replication itself
Now-
is
now you have to
kind
be
of,
careful
did
with
this,
this.
it never did work-based, to begin with, it did state
Looks like a
stuff until
table.
like 2
Behaves
years
like
ago.
a table.
Okay, so that's
So if
So,
you try to do
it was
jobs
just like,
in
oh,
this,
read the stuff that's in the binary.
Okay, so that's
sense.
all. Part of the problem with this logic is it builds a table that iterates.
So if your data
I mean,
was out of
instead
sync,
of FTP, you
can just reapply the statement.
no, well, it wouldn't reapply the statement. If your data was out of sync and you ran a statement, like an update statement that it matched differently, then you update things differently.
So
You can do things
Yeah,
like
that would be why my
delete
presentation is on how to
you can
check to
do
see if
things
everything's
like
in sync and how to sync it if it's not.
But if you start doing
I don't have to
joy,
go to the airport.
No, that's not.
this doesn't work.
So this actually consists
Yes, we
of a
looked at
database, let's say 10 tables. So what you would say would be make 10 tables locally and then create 10 real tables, federate tables, and once it's done
And
building.
then continue and you come back and go, well, it's not SQL camp, here's how to solve that.
Yeah, I'm gonna take all DB then.
10 tables about,
Okay, so you put 10 tables here, and you make sure that these
Categories of
Tables.
SQL space.
Is it
I think it's not NoSQL. It's like it had, you use SQL, it's a relational database. It's like, but people, like, I think every new database these days is just like, oh, that's NoSQL. Like, they're just not thinking about it.
unless
Yeah,
you
it's not NoSQL. It's not even.
so we don't tell that not to replicate.
Because I said,
Every day we basically drop these and build
And that's something that
scratch
you
about
can think
20
about,
gigs worth.
do we want to bring in more?
Every Sunday. Like if
Like
you
the
do
stuff.
incrementals on Sunday.
I've done that several times. This can work if you are careful.
It's so different.
If
It's
you
just
know
like,
what
oh,
you,
it is.
Yeah,
what you
but
want.
it's still cool.
For instance, I use this.
It's definitely, again, yeah, definitely cool. But it's kind of like, well, we're kind of putting my skill in there, and we just put everything in there, and what's going to go on.
No,
That's exactly what I'm asking there.
I build the summary tables here, and then I transfer them to the master.
By using the federated.
Yes, but in my case, I want them to be replicated.
No, whole DB is definitely
To
different.
other places.
Other than
Yes,
also
because I
I
want
think that
every
is
slave
it.
to have the summary table.
So,
But I don't want every the calculation.
no, I get that. So yeah, for us, that would be ideal if we do some
Very similar to
incremental, like I said,
Like it has,
blow away
a
every
Google
Sunday,
transaction here has, you know,
blow away those tables, and they are,
Yeah.
many gigs.
How long does it take to produce?
I'm glad you enjoyed. Did you get it?
It takes about 4 hours or so to compute and build those. So I'm concerned that if we do that, and it's continually writing that to the binary log, because it write all those inserts into the binary log over here, wouldn't it, for replication purposes?
Yeah,
Okay, now,
it'll
where do
happen,
you
one way or
use
another.
these tables?
Uh,
All in the master.
yes,
You don't need to have that.
yes. Or we could have non-fresh data in slave, so we can get that
People,
So
flow process.
if you don't need them in the space, you just remove them from the binary. So you
no
fit
problem, I'm glad you came and I'm glad we enjoyed part of the little, you know, the whole lot. I mean, I thought we'd have people here and, you know,
MySQL things like
everything's crazy. Oh,
scripts and things over, blah,
Yeah.
blah.
networking. Hello, this is Shiri.
This is a lot cleaner. Like,
Okay, yeah, just to be
Mhm.
careful with federated.
what are some of the dangers that we have to keep our eye on?
is very naive. So if you do a select
Yeah, in the data center.
from a federated table, it will internally do a select.
It's the weird, crazy
So
building.
on here,
I think,
don't build
yeah.
using
Go to the
federated
fourth
tables if
floor,
you're building
and
the
basically,
normal
there's two sets of elevators, but the two sets of elevators are like either side of the building. If you go to the fourth floor in the middle, so basically you go into the elevator and, you know, just wander around, you'll find like there's a big meeting space in the middle. And a woman named Suze should be there. And she'll be able to like sign stuff and do everything, if that's all right.
And I send this to a federated table.
Yeah, fourth floor.
So in the master there will be a table with the situation of the replication of all the slaves. The only thing that the slave do.
If you came in the Dreyfus building in the fourth floor, when you get out of the elevator on the fourth floor, you kind of like make a, you know, you go like, you have to go left out of the elevator. There's like a big glass wall in front of you. There's nothing, you can't go right. But basically there's a frosted glass doors, and you want to go through them, and just keep going straight out of them, and you'll see the little the lunchroom kind of thing. Okay.
We'll be now sending the entire bandwidth
Thanks.
of
Bye.
all those non-compressed across. So that may or may not be an issue. Because this has to, if you're not doing federated, not only do you have to transfer it, but then on top of it you have to do the MySQL load. So you're doing some degree twice the work, because this machine then has to unzip that file and then do the DB insert for the load, the SQL dump that we took from there and transferred over. So this would take some load on this machine with the bandwidth.
Hello, this is Shiri.
Okay.
Hey, Noam, how you doing?
Bandwidth, I think is not an issue at 4 in the morning.
Hi, Adam or Sam. Is it Adam?
I
No,
will use a
that's
dedicated
Adam.
switch for that.
That's Sam. Wow. Hi, Sam.
Office, hosted servers.
Hi,
Central
Sammy.
location off in the magic sky somewhere.
Servers. Yeah.
You can do that. You can do that. How big are these tables?
Like I said, we have a couple of them that are have maybe like 4 or 5 million rows. Gigabytes.
I could try to Skype right now.
Well, say 10
I'm
gigabytes.
at MIT right now, so I don't know if it's gonna work. But I'll try.
It's not a big deal.
Oh, local network, yes, but to send that up to here.
Just in this, you don't have to do. You don't have to do.
Yeah. That's yeah. So they happen all at once. It's not nice. It's not like 10 gigabytes across. This gets calculated and then boom, and it needs to be up there in the morning before. You know what I mean?
With the federated, it's always going to be accessible local from the remote, right? Because the federated doesn't keep a local copy on the remote. It uses a connector to connect to the local.
Now, the only problem that you have with the federated, actually the biggest problem that you have with the federated is that it's synchronous. So if it's down, it doesn't work. It gives you an error, but it doesn't catch up, like replication.
Yeah. Well, right now what happens is it locks the entire. And while this is uploading, it takes probably about, I would say, an hour or two to do the data upload back into MySQL, to drop the existing tables and load the dump that we've got from there. And that entire time, it basically freezes those reporting sites for those tables.
Now, you can use store procedure to check if the federated table is connected or not. I wrote an article in 2006 describing how to do this. You can find in dev.mysql.com articles. Look for advanced MySQL replication techniques. There is something like that. Something like this.
This is definitely something for us to look at. Like, it simplifies things a lot, but it's just that bandwidth and moving the data across once a week at that time. If it can't complete that within a few hours, we would have a problem.
Why not? What about using, so what we do every couple days, we have process errors nightly, and we have data that sits in basically one set of tables that we have to have available at all times. But the data has to be refreshed back in order for us to always have available data. What we do is we basically swap nightly between basically two tables. We have a view that sits on top.
Oh, I get it, yeah.
So you load into one view,
Yeah,
you have the secondary, the view looking at the secondary
Then you
view,
just change the view.
and then you just swap the view.
That seems actually like a smart idea for us.
And if you're only doing it once a week, you don't have to worry about it always swapping back and
Yeah,
forth.
no.
Now, there is another trick to transfer big chunks of data across the network.
Oh, wait. Does using the view to just switch the name like that cause any problems when you join to, if you join to those tables?
We haven't seen any issues.
Okay.
Because it's literally just, you drop the view, you bring the view back up, and that's all you have to do. It's literally split.
And the view is select star from table? Or?
Well, the view is basically, yeah, select start from table, just table 1 or table 2, whatever one you're supposed to be looking at. And it gets all of our data.
That might be a nice added way to maintain, so if for some reason it doesn't build or something like that, it's still up.
Right.
We just don't have the latest data.
Right. I mean, our tables aren't really, they're 200, 300 megs, but they always have to be up.
Yeah.
So there is a trick that you can use to transfer big chunks of data. You can do that using an external application, or you can do a store procedure. What needs to do, you have to convert your data into multiple insert statements and squeeze them and transfer the blob to the network, and here you have to expand it. Now, let me try to remember the case. I did this in 2005, so it's a long time ago.
That seems almost as complex as doing a zip the MySQL dump, send it across, unzip it, load it.
Now, if you the easiest thing to do is with MySQL dump, pipe into the remote database.
That would be easy, but you have to compress it first.
Yes, MySQL dump, compress, send it to the external, pipe it to G and zip, and then.
Right into. Oh, yeah. Well,
so you across the network you only transfer the
zip
file.
stuff down, yeah. Yeah, but the only issue we would have is almost kind of like the same thing as if it died sometime in the middle of it. That would, because the first thing we did, that thing does is drop the existing tables.
And you should probably have something where you rename it, or you have a separate set of tables and you do the view switch.
That's
We always
that
grab
is
the-
something
the
that.
exec- in case of emergency, you grab-
Depending on what you need to do, you can use archive tables. Now I'm trying all the tricks in the training. You know archive tables? Okay, archive tables are like normal table, except that you can only insert in them. You cannot delete or update.
That's fine.
The good thing is that they occupy roughly 10% of the storage.
Are they as fast as the regular tables as far as doing reads?
It depends on what you do. I mean, you cannot put indexes on that.
So we're thinking of trying out well, first of all, creating a different MySQL.
So if you have 10 gigabytes, if you squeeze it to archive, it becomes 1 gigabyte.
Yep.
Now, archive.
Oh, so archive on that side and transfer the archive table
Mhm.
across. I get it. Okay.
Now, depending on what you need to do, you can use archives instead of regular tables, and you get better results than MySQL or ELB. When does this happen? When you need to do statistics. So statistics, you usually do things like give me all the data related to 2007. So you are something like that, archive with partitions, is wonderful. For two reasons. First, because when you read from disk, you read only 10% of the storage. So if you take a MySQL table, you are reading 10 gigabytes of data.
Yeah.
If you are taking archive, you are reading only 1 gigabyte.
But then you have to make sure you partition it properly based on what you're looking for. Because without the partitions, you're screwed.
But I have a trick for that. And for this, the way it seems very dead. So one thing that I do is this. Since archive are very cheap, so it costs me only 1/10 of the storage, I have three instead of one. So if I have to partition by date here, by property here, and by location, it costs me 30% of the storage.
Sure. Yeah, that makes sense.
So
That's
this is something that doesn't cost me much. So you keep the master, and then you know, depending on what you need to do, you can set up the slaves in the same machine. So you don't need an additional host for that.
Yeah, I mean, we're thinking of doing similar to maybe moving from using our DB or MySQL tables to using giving a shot with the column-based storage stuff, like the InfoBright, because they have supposedly very fast loads. We're doing bulk loads, and we're only doing reads off of it.
It's a big deal though. I mean, if you need to do something very complex, yeah, go for it. But before doing that, do some benchmarks with partition to see if they solve the problem. Because I have seen many people who have used partition even before MySQL fragment were GA, just because they could solve most of these kind of problems very easily. Kind of problem that you can solve with partitions are if you have recurring data that you need to produce and then get rid of after a month. With partition, you can just remove them in less than 1 second. So you just need to drop partition and then go. If you need to delete them from a MySQL or EDB table, it takes minutes or hours. What else you can do? You can create new partitions month by month, or week by week, or day by day, and without automatically in the background. So if you go into the archive, into the articles section of MySQL.com, you will find testimony from a couple of customers who did that.
Okay.
And not only that, they are also the scripts that they used to create the SQL. Not only they did this thing with the archive and partitions, they also used lens to do everything in SQL. So it was self-contained.
I don't want to, if anyone else has any questions.
Okay, it's cool to know these kind of things.
So right now we're not using replication, we just don't have enough. Basically what we have going on is we have our public here, and that's on a remote server. And every night I'm doing, basically FTP download, not actually FTP, but, and then that's a SQL dump file. And then I'm loading it into a local table. And then doing a lot of reporting and everything on it. So, I mean, one thing that I'm considering, is instead of doing this process, is just to set up a local slave here that is automatically getting.
Yeah, why didn't you do that?
Because this was set up with MySQL 3.2 a lot.
This is upgraded
We've upgraded the version, but the whole process has been set up since a long time ago. So, replication, considering here, I was also wondering, so definitely do that, and then, just do all the reporting on that.
You don't do any transformations, or you don't write to that local copy? It's
Well,
for
so
reading?
that's only for reading, and then we have a bunch of other things. I mean, we have some reporting databases that would probably be helped by the archive thing you're talking about, because right now we go through this copy public data and, sort things by time and put it into different, bunch of different lookup tables and reporting tables, which might be, be able to automate with the archive that you're just talking about. So, I mean, obviously that sounds like a good idea. What about having a slave on the same server that you could, like, in order to do things like the dump right now, where it kind of stops the database, our data set's not huge, so it stops it for a couple minutes, but just a local slave
Replication.
can do that.
You can do that. You have to consider that this operation might be CPU intensive and IO intensive also. I mean, what do you need to do? Take a dump and squeeze it. So if you have several processors in your host, it could be a piece of cake, or it could stop the whole master. So you have to test it. Usually it's not a big deal. I have done that. I have done that. So if you know that the process doesn't require too many resources, it's not a big deal.
And you don't lock anything. When you're doing replication, you never lock anything. Nothing's ever locked. And we did something similar where we weren't really replicating everything. We were dumping it.
Yeah.
We started to discover replication.
The advantage of replication over FTP, not only that they don't have locks, but also it's smart. So if you lose connection here, then you have to redo from scratch. If you lose connection with replication, eventually when you